Hello friends, welcome back to our channel. Let's learn and grow together. In the last lecture, we have covered different types of stresses and their corresponding strains. So today we are going to cover the concept of elastic limit, definition of Hooke's law, different types of elastic constants and the relationship between them. So let us start with the elastic limit. So what is elastic material? A material when loaded gets deformed. A material when loaded gets deformed, but when this load is removed, material will go back to its original dimensions. When a material is loaded, it gets deformation. That is nothing but the material will offer resistance to this deformation. That is nothing but stress. So this resistance against the deformation is stress. So when this material is unloaded, what happens? Deformation disappears. So stress or the resistance will also disappear. So this property of material of regaining its original dimensions is called as elasticity. This property of material to regaining its original dimensions after removal of an external loading is called as an elasticity. But this is possible only when this is possible only when deformations caused or stress generated are within certain limit. So this limit is called as elastic limit. So when the stress or the deformation is within elastic limit, material will regain its original dimensions. When stress goes beyond elastic limit, it is not possible for a material to regain its original dimensions and there will remain some amount of permanent strain. तो इलास्टिक लिमिट का मतलब ये है कि जब तक डिफॉर्मेशन और स्ट्रेस आर विद इन इलास्टिक लिमिट तब तक मटेरियल उसके ओरिजिनल डायमेंशंस में रिटर्न आ सकता है, तब तक मटेरियल इसके अपने ओरिजिनल डायमेंशंस में रिटर्न आ सकता है. So this is about elastic limits. A English mathematician, Robert Hooke, performed several experiments and he concluded that within elastic limit, Robert Hooke concluded that when stress is within elastic limit, when stress is within elastic limit, the ratio of stress and corresponding strain is constant. The ratio of stress and corresponding strain is constant. That is nothing but stress is directly proportional to strain within elastic limit. So now in case of axial loading, tensile or compressive stress is directly proportional to tensile or compressive strain. So in case of axial loading, that is nothing but tensile or compressive stress, sigma is directly proportional to strain epsilon. So sigma by E is equal to constant, and the constant of proportionality in case of axial loading is E, which is known as Young's modulus or modulus of elasticity. Young's modulus or modulus of elasticity. So this is the first elastic constant, that is Young's modulus. E is equal to stress upon strain. So another case of loading is in case of shear loading. Shear stress is directly proportional to shear strain. That is nothing but shear stress tau divided by shear strain phi. This ratio is constant, and the constant of proportionality in case of shear loading is denoted by G or N or C and is known as shear modulus or modulus of rigidity. Shear modulus or modulus of rigidity. So this is second modulus, that is G is equal to tau by phi, shear modulus or modulus of rigidity. So the units for this modulus of elasticity or modulus of rigidity are same as that of the units of stress, because strain is unitless quantity in both the cases. So units are same as that of stress, that is Newton per mm square or megapascal. So now we'll see the third elastic constant, that is nothing but bulk modulus. So this bulk modulus is extension of Young's modulus, extension of Young's modulus in 3 dimensions. Extension of Young's modulus in 3 dimensions. So when a body is subjected to identical stresses sigma in 3 mutually perpendicular directions, the body will undergo deformations. As 3 uniform or identical stresses are applied on 3 directions, the body will undergo uniform changes. मतलब सभी साइड्स को ये यूनिफॉर्मली डिफॉर्म होंगी, तो इसका शेप चेंज नहीं होगा, इसका वॉल्यूम चेंज होगा. सो इन सच टाइप ऑफ लोडिंग a change in volume to the original volume is called as volumetric strain. Bulk modulus is actually an extension of Young's modulus in 3 dimensions. So due to such type of loading, material will undergo change in volume. So change in volume to the original volume is volumetric strain. So here bulk modulus is defined as K, it is denoted by K, and it is defined as the ratio of identical stress acting in 3 mutually perpendicular directions to the volumetric strain. The volumetric strain is nothing but bulk modulus, that is K is equal to volumetric strain, identical stress sigma divided by volumetric strain. So this is bulk modulus. Now we will see the fourth elastic constant, that is Poisson's ratio. So when material undergoes change in dimension in longitudinal or axial direction, it undergoes change of opposite nature in lateral direction. So what is this? Take an example. When a materials or structural member is subjected to an load P, equal and opposite forces, external loads, what will happen? They are pulling this structural member, so the length of this structural member is going to increase. So in longitudinal direction, what will happen? Longitudinal direction, the length will increase, that is nothing but elongation. But at the same time, the other dimension, suppose this is circular rod, so the other dimension, which is diameter of this rod, that is in lateral direction, the diameter is going to reduce. That is nothing but contraction. So this elongation in the longitudinal direction is linear strain, which we have seen up till now is linear strain. But the contraction, that is change in diameter to the original diameter, this strain is called as lateral strain. This strain is called as lateral strain. But it is found that the ratio of lateral strain to the linear strain, the ratio of lateral strain to the linear strain is constant, and this constant is called as Poisson's ratio. Poisson's ratio. It is denoted by mu. So mu is equal to lateral strain divided by linear strain minus, here negative sign is because both the strains are of opposite nature. So when longitudinal direction elongation, so this is positive strain, contraction it is negative strain, so mu will become negative. Suppose when the longitudinal direction we applied here pushing forces, so we will get here negative strain, and in lateral direction diametral linkage, so positive strain, so here also you will get negative sign. So mu is equal to minus lateral strain upon linear strain. So mu is also unitless quantity. For most of metals, mu is in between 0.25 to 0.33. For steel it is 0.3. So it is less than 1, that means lateral strain is less than the linear strain. Poisson's ratio is also denoted by 1 by m. So now we will see the relationship between these elastic constants. So the relation between E, that is Young's modulus, and shear modulus is E is equal to 2g into 1 plus mu. Another relation is relation between Young's modulus and bulk modulus, that is E is equal to 3k into bracket 1 minus 2 mu. There is another relation in between Young's modulus, shear modulus and bulk modulus, which is E is equal to 9 kg divided by g plus 3k. अगर हमने इसको सिंप्लीफाई कर दिया तो ये आएगा E बाई 9, सॉरी ये आएगा 9 बाई E, so is equal to g plus 3k divided by kg. So therefore 9 by E इज इक्वल टू जी बाई के प्लस के जी में जी जी निकल जाएगा, सो 1/k प्लस 3k/kg में के निकल जाएगा 3/g, सो दिस इज 9/e is equal to 1/k plus 3/g. So these three relations are important in problem solving, and in some exams they will ask it as them in objective type questions. So this is it for today's lecture. To get updates regarding our next videos, please subscribe our channel and stay tuned. Thank you very much.